Hello everyone, welcome to new class. Today's class is the continuation of the problems related to signal flow graph, that is to find the overall gain of the system from the signal flow graph. So if you didn't watch the previous class, please go through it. The link will be given in the comment box. And I have taken classes related to the basic electrical engineering, then digital electronics, and now I am taking classes on control systems and also basic mechanical engineering. So, and all are listed in the playlist. So please go through the playlist and watch your subjects. So let us do the problems. First one is find the overall gain of the system whose signal flow graph is shown in the figure. So this is the given figure. So here the nodes are not numbered. So our first step is to number the nodes. So let this node be 1, then 2, 3, 4, 5, 6, then 7 and 8. So there are 8 nodes in this figure. Now next step is to find the forward path. That is number of forward path. So first forward path is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This is the first forward path. In this manner, here also there is a forward path, that is 1, 2, 7, 8, 5, 6. 1, 2, 7, 8, 5, 6. Now next is 1, 2, 3, then 8, 5, 6. 1, 2, 3, 8, 5, 6. So in this way here also another forward path, that is 1, 2, 7, 4, 5, 6. 1, 2, 7, 4, 5, 6. And next is 1, 2, 3, then 8, 7, 4, 5, 6. So here there is another forward path like this. That is nodes are 1, 2, 3, then 8, 7, 4, then 5, 6. So this is in this way. Likewise here also the one forward path is there, 1, 2, 7, then 4, 3, 8, 5, 6. That is 1, 2, 7, 4, 3, then 8, 5, 6. So one is like this, next is like this. So there are 6 number of forward paths and we have to find the forward path gains. So gains, forward path gains, let it be P1, first one P1, that is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the gain product is G2, G4, G6. G2, G4, G6. Next is P2. P2 is 1, 2, 7, 8, 7, 8, 5, 6. That is G3, G5, G7. G3, G5, G7. Next is P3. P3 is 1, 2, 3, 8, 5, 6. 1, 2, 3, 8, 5, 6. So this is G2, G1, G7. G2, G1, G7. Then P4. P4 is 1, 2, 7, 4, 5, 6. 1, 2, 7, 4, 5, 6. That is G3, G8, G6. G3, G8, G6. Next is P5. P5 is 1, that is 1, 2, 3, 8, 7, 4, 1, 2, 3, 8, 7, 4, 5, 6. 1, 2, 3, 8 in this way. 7, then 4, 5, 6. So G2, G1 minus H2, G8, G6. That is G2, G1. That we can write G1, G2, then minus H2, G8, G6. G6, G8 minus H2. Next is P6. So P6 is 1, 2, 7, 4, 3, 8, 5, 6. 1, 2, 7. That is G3, then G8 minus H1, G1, G7. So G1 is there, minus G1, 1, 2, 7, 4. G3, G8, G3, G8, then minus H1, G7. So G7 is there, minus H1, G1, G3, G7, G8, H1. So these are the forward path gains. Next we have to find the individual loop gains. So for that we have to find the individual loops. So individual loops are, so this is one loop and this is another loop. And there is one another loop, that is from here we can take 3, 8, 7, 4, then 3. So this is another loop. So the individual loops are, one is 3 to 4, next is 7 to 8, and another is 3, 8, then 7, 4, 3. 3, 4, 3, 7, 8, 7. So these are the individual loops. So for the first individual loop, the gain is G4 into minus H1. For this second one, G5 into minus H2. And for the third loop, we get G1 minus H2, G8 minus H1. So individual loops are, let P11 be the first one. So it is minus G4H1. Then P21 is minus G5H2. Then the third one is P31, and that is G1. Then G8 minus H2 minus H1, that is it will be positive H1 H2. So there are 3 individual loops. Now we have to find the gain product of two non-touching loops. So there are 3 loops. Out of these 3 loops, we have to find the 2 non-touching loops. So these 2 are non-touching, and this is another loop, and which is touching the other 2 loops. So only there are one pair of 2 non-touching loops, and there is no 3 non-touching loops, since only there are 3 loops, and there are no 3 non-touching loops. So only one pair of 2 non-touching loops are there, and that is this one and this one. So let the gain product be P12, and that is equal to P11 into P21, and that is G4 G5 H1 H2. Now we have to find the values for delta and delta K. So delta equal to 1 minus sum of individual loops. So individual loops are P11 plus P21 plus P31, then plus sum of plus gain product of the 2 non-touching loops, that is here only 2 non-touching loop, so P12. So all the terms we have already written. So we get delta is equal to 1 minus G4H1 minus G5H2, then plus G1 G8 H1 H2, then plus P12 is G4 G5 H1 H2, and here we can write 1 plus opening the bracket G4 H1, then plus G5 H2 minus G1 G8 H1 H2, then plus G4 G5 H1 H2. So this is delta. Now we have to calculate the values for delta K. So here we have to find delta 1, delta 2, delta 3, delta 4, delta 5 and delta 6. So delta 1 is delta for the part of the delta for that part of the forward path which is not touching the for this forward path. So here for delta 1, this is delta 1, and we have to find delta 1. So delta 1 is 1 minus sum of individual loops. So for this forward path, the individual loop is this one. So 1 minus this one, that is 1 minus G5 H2. So we get 1 plus G5 H2. Next is delta 2. So delta 2 is delta for that part of the graph which is not touching the second forward path. So second forward path is 1, 2, 7, 8, 5, 6 and 1 minus sum of individual loops means this is the individual loop. So 1 minus G for H1. 1 minus G for H1 and that is equal to 1 plus G for H1. Next is delta 3 and delta 3 is delta for that part of the graph which is not touching the third forward path. That is third forward path is 1, 2, 3, 8, 5, 6. 1, 2, 3, 8, 5, 6. So here the loops are touching. So delta 3 is 1 for 1. Then for the fourth path 1, 2, 7, 4, 5, 6. So in this case also all the loops are touching. So delta 4 is also equal to 1. Then for the fifth forward path 1, 2, 3, 8, 7, 4, 5, 6 and also for the sixth forward path 1, 2, 7, 4, 3, 8, 5, 6. In these cases all the loops are touching. So delta 3, delta 4, delta 5 and delta 6 are equal to 1. So we can write delta 3 equal to delta 4 equal to delta 5 equal to delta 6 equal to 1. Now we can find the transfer function using Mason's gain formula. That is T is equal to 1 by delta sigma k pk delta k and that is 1 by delta P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 plus P5 delta 5 plus P6 delta 6. Now substitute all the values. So P1 is G2, G4, G6 into delta 1 is 1 plus G5 H2, then plus P2 is G3, G5, G7 into delta 2 is 1 plus G4 H1, then plus P3 is G1, G2, G7, delta 3 is 1, then plus P4. P4 is G3, G6, G8 into 1 plus P5 is minus. So this is minus G1, G2, G6, G8, H2. Then P6 is minus G1, G3, G7, G8, H1 whole divided by delta is 1 plus G4 H1 plus G5 H2 minus G1 G8 H1 H2 plus G4 G5 H1 H2. So this is the transfer function for the given signal flow graph. Let us do another problem. The signal flow graph for a feedback control system is shown in the figure. Determine the closed loop transfer function C of S divided by R of S. So this is the given signal flow graph. So first of all we have to find the forward paths. So number of forward path. So there are 6 nodes and this is one forward path 1, 2, 3, 4, 5, 6. Then next forward path is this one, that is 1, 2, 3, 5, 6. So there are two forward paths and these are loops. So find the forward path gains. Let the first one be P1 and P1 is equal to G1, G2, G3, G4, G5. 3, G4, G5. Then P2 is equal to G1, G2, G6, G5. G1, G2, G6 and G5, G5, G6. So these two are the forward path gains. Now we have to find the individual loops. So individual loops are, one is this one, 2, 3, 2. Next is 3, 4, 3. Next is 4, 5, 4. And also there is one another forward path individual loop, that is 3, 5, 4, then again 3. So this is also an individual loop. So there are 4 number of individual loops. So 4 individual loops are there. One is 2, 3, 2. Next is 3, 4, 3. Next is 4, 5, 4. And the last one is 3, 5, 4, again 3. So there are 4 individual loops. So individual loop gains we have to find. For the first individual loop, the gain is G2 H1, second one G3 H2, third one G5 H3, then the fourth one G6 H3 H2. So first individual loop gain is P11 equal to G2 H1, then P21 is G3 H2, P31 is G4 H3 and P41 is G6 H2 H3. Now we have to find the gain product of two non-touching loops. Two non-touching loops. So here there are 4 loops and this loop and this loop are the two non-touching loops and there is no other two non-touching loops. So P11 into P31 are the two non-touching loops and there are no 3 non-touching loops in this signal flow graph. So P12, that is two non-touching loops, are P11 into P31 and that is equal to G2, G4, H1, H3. Now we have to find the values for delta and delta K. And delta is equal to 1 minus sum of individual loops, and some individual loops are P1 and P2. Sorry, P11, P21, then P31, P41. That is P11 plus P21 plus P31 plus P41. Then plus sum of gain product of two non-touching loops, and that is here only one, that is P12. Now put the values. 1 minus G2 H1 plus G3 H2 plus G4 H3 plus G6 H2 H3, then plus G2 G4 H1 H3, and that is equal to, open the bracket, 1 minus G2H1 minus G3H2, then minus G4H3 minus G6H2H3, then plus G2G4H1H3. Now we have to find the values for delta 1 and delta 2. Since this is delta K, there is two forward path. So we have to find delta 1 and delta 2. To find delta 1 is delta for that part of the graph which is not touching the first forward path. So this is the first forward path and there is no individual loops for this first forward path. So delta 1 is equal to 1 and we have to find a delta 2. So delta 2 is delta 2 for that part of the graph which is not touching the second forward path. So this is the second forward path and there is no individual loop which is not touching the second forward path. So delta 2 is also equal to 1. So delta 1 equal to delta 2 equal to 1. Now we can find the value for transfer function using Mason's gain formula. That is transfer function equal to 1 by delta sigma k pk delta k, and that is equal to 1 by delta p1 delta 1 plus p2 delta 2. So here p1 is g1 g2 g3 g4 g5 into delta 1. Delta 1 is 1, then plus p2 is g1 g2 g6 g5, then divided by delta. Delta is 1 minus g2 h1 minus g3 h2 minus g4 h3 minus g6 h2 h3 plus g2 g4 h1 h3. So this is the transfer function C of S divided by R of S. So this is about the problems related to signal flow graph. In the next class, let us study about the signal flow graph from block diagram. That is, we have to find the signal flow graph from the block diagram and then we can find the transfer function. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.